Is f differentiable at x equal to? To prove that, we have function f of x, piecewise function. It is equal to 2x minus 1 if x less than or equal to, and it is equal to x squared if x greater than 2. To prove this, we should do what? We should find the limit. We should find the limit. Okay, just 1 minute to get the pen. We should find the limit. Okay, just a minute again. All right, we should find the limit of f of x, limit of f of a plus h minus f of a over h as h tends to 0 minus, and this is where x tends to, if h tends to 0 minus, this means x will be tends to 2 minus. And we should find also the limit of f of a plus h minus f of a over h as h tends to 0 plus, and this is where we should do x tends to 2 plus. If h tends to 0 plus, this means x tends to 2 plus, because x equals 2. If these two limits are equal, this means for sure it is differentiable. Here we have to know if it is differentiable at x equal 2 or not. But in both cases, we have f of a. Where we find f of a? Here f of a means f of 2, because x equal a, x equal 2. This means at x equal 2, what is f of a? F of a, here, it's f of 2. Where do we find 2? And we substitute it in both of them. Even if x tends to 2 minus or x tends to 2 plus, here exactly we need to find f of a. What's the meaning of f of a equal f of 2? This means at x equal 2 exactly. At x equal 2, it's here. So we substitute 2 instead of x in the part where f of x equal to x minus 1. Then it is equal 4 minus 1 equal to 3. Now, let's find the limit. Limit of f of 2 plus h minus f of 2 over h as h tends to 0 minus. What is that equals to? Its limit as x tends to h, as h tends to 0 minus, approaches 0 minus, of what? Of f of 2 plus h. As h tends to 0 minus, this means when x tends to 2 minus, this means also in this one here, we have to substitute instead of x, 2 plus h. It's 2 into 2 plus h, and we have beside it minus 1, minus f of 2, and we found it as 3. So we found it as it is equal to 3 over h, which is equal limit as h tends to 0 minus of 4 plus 2h, I'm expanding the minus 4 over h, which is equal to limit as h tends to 0 minus of 2h over h. We can cancel the h. The answer is 2. This is at 0 minus. Let's find it as at 0 plus. Limit as h tends to 0 plus of f of 2 plus h minus f of 2 over h is equal to limit as h tends to 0 plus of, now we have h tends to 0 plus means at x tends to 2 plus x greater than 2, we find it here. What is f of x in this case? It's x squared. So instead of x, we substitute 2 plus h. It's 2 plus h to the power 2 minus f of 2. F of 2 again, we already found it to be 3. So it's minus 3 over h. Also expand, it will be limit as h tends to 0 plus of what? Of 4 plus 4h plus h squared minus 3 over h tends to 0 plus means over h. We should simplify this. We should simplify this. We do what in this case? Let's equal limit. Okay, let me continue here. Its limit as h tends to 0 plus of, okay, it's h squared plus 4h minus plus 1, it's 4 minus 3 over h. Okay, we have a problem here, right? Because we have to get rid of h. To get rid of h, we should do what in this case? Limit as h tends to 0 plus, we take h common. In the numerator, it will be h plus 4 plus 1 over h over h. Can we simplify the h now? We can simplify the h. What left is this, h plus 4 plus 1 over h. If we substitute 0, we get 0 plus 4 plus 1 over 0 plus. So the answer is 1 over 0 plus is plus infinity, plus 4, it's plus infinity. Okay, so is the limit at 0 plus equal the limit at 0 minus plus infinity? Is it equal to 2? Not equal, so not differentiable. But I want to say something here. So f of x or f is not differentiable at x equal 2. This is how we test if a function differentiable at a point or not. If we, from the beginning, we started with this, which is limit as h tends to 0 plus, and we found it to be plus infinity, for sure it will not be differentiable because we have plus infinity. We don't continue to get the h minus if we want, because we don't continue to find the h as h tends to h tends to 0 minus. Why? Because even if h tends to 0 minus gives me like plus infinity, this means in this case it's not differentiable. F will not be differentiable, and we will have a vertical tangent. We will have a vertical tangent. Here we don't have vertical tangent, but it's not continuous. It's not differentiable. F is not differentiable at x equal 2.